So let's switch gears and move into our presenting our guest speaker. We are so lucky this evening to have Dr. Donald Boesch with us. Our guest speaker is a professor of marine science, and from 1990 to 2017, he's the president of the University of Maryland Center for Environmental Science. From 2006 to 2017, he concurrently served as vice chancellor for environmental sustainability for the University System of Maryland. He is currently a senior scholar with the Gulf Research Program of the National Academy of Sciences. Dr. Boesch is active in extending knowledge to environmental and resource management at regional, national, and international levels. He was appointed by President Obama to the National Commission on the BP Deepwater Horizon oil spill and offshore drilling in 2010. He has a long record of service to the National Academy of Sciences, serving as chair to the Ocean Studies Board and member on the Committee of America's Climate Choices and Advisory Board of the Gulf Research Program. He is currently on the Leadership Council of the Joint Ocean Commission Initiative and the Advisory Board for BONUS, Science for a Better Future of the Baltic Sea region. Born and raised in New Orleans, he received a BS in biology from Tulane University and a PhD in oceanography from the College of William and Mary. After a Fulbright postdoctoral fellowship in Australia, he spent 8 years as a faculty member at the Virginia Institute of Marine Science. Please join me in welcoming Dr. Boesch.
Thanks very much, Kyla, and I'm really pleased that you've turned out tonight to watch the film and hear me a little bit too. So it's kind of interesting to see the participants come up from all over the country, and most of you who identified in talking with Kyla, you know, a lot of them from inland states, far removed from the ocean. But I can assure you that where you live was once part of the ocean, number one. And secondly, almost all of you, except for a small area around Great Salt Lake, live in areas that drain to the ocean. And all of you are influenced by the ocean in terms of your weather and climate in major ways. So I hope you can kind of instill in that connection with your students and the people you're working with, that we're all connected to the ocean, we're all dependent on it. Now, what do most people think about when they think about climate change in the ocean? Well, you know, one of the questions dealt with one of them, that people are concerned about sea level rise and whether this is going to inundate coastal cities and coastal habitats and so on. You know, some people probably have heard about the ice disappearing, you know, the floating ice in the Arctic disappearing rapidly, concerns about polar bears and so on, but relatively few people can go much beyond that. So what I want to do is just to kind of talk about the various ways that the oceans are affected by climate change, but also or moderate and control the climate that we have and how that's all changing in a rapid way. And then also what you can do as citizens, teachers, and so on to help us address this problem, this crisis of the climate, and particularly related to the connection with the ocean. Well, first of all, first principle you need to understand is that the ocean is where most of the heat on the surface of the ocean, or surface of the planet, is stored. You know, well over 90%, 95% and so on of the stored heat is not in the atmosphere or on the surface of the lands, but is in the ocean. And that's been accumulating heat as the planet's warmed. So we can actually see this, you know. So if we think of if we look at the variations in temperature on the surface of the Earth, you know, it goes up and down some years. In fact, that's part of the controversy, right? People said, well, you know, it's going down these few years, so climate change is not a problem. It goes up and down depending upon cycles, climate cycles and volcanoes and a whole bunch of other things. But the heat content of the ocean is just progressively increasing from time to time. So if you want to see one unequivocal record of global warming, it's look at the heat content. You can look at this on the web, heat content of the ocean. You can see how rapidly it's growing. Now, that has many consequences. including that it's building up this heat and it gives back that heat to the atmosphere on occasion. So if you hear about El Nino events, that's basically a time when the ocean is kind of transferring more heat back into the atmosphere. And it means that our atmospheric climate is kind of on a flywheel. It can't go back too far because the ocean's always there to keep it, give back its heat and keep the planet warming. So it really portends that this is, a long-term direction, and it's not going to change quickly because of the tremendous amount of heat stored in the ocean. Now that has other very practical implications too, because of that storage of the heat, it's able to transfer that heat sometimes pretty rapidly, and the moisture, the water from the surface of the ocean associated with transferring the heat to the atmosphere. And that's what's resulting in this global pattern we see now of intensification of tropical storms and hurricanes. So, for example, Kyla mentioned that I'm doing this work in the Gulf of Mexico. And you all know, you've seen in the news, the tremendous number of hurricanes that have occurred down there last year. Now, hurricanes, intensity varies from year to year, number of hurricanes. But one of the things that's quite remarkable is that hurricanes are intensifying much more rapidly than we've seen in the past. And that's pretty well pegged to when they cross over an area of warm ocean water that's deep enough that they can't stir it up and get to the cool water. And so they're just drawing their heat, this heat engine that is a tropical storm or tropical cyclone, and drawing the moisture. So this is why we had these tremendous rainfalls associated with Hurricane Harvey. Just this year in Louisiana and Texas, we have these tremendous rainfalls because of these stall systems that just drawing all of this heat and moisture from the warm Gulf of Mexico. So, and this actually transfers all the way, it affects me here. I live in Maryland. As these remnants come up and the water is drawing off, the moisture is drawing off of the warm Gulf and causing rainfall patterns and intense precipitation all over the country. The other thing that's the oceans do is they also absorb a lot of the additional CO2 that we're adding. So we're adding this, every year we're adding, seems to be more and more CO2. We've built up now well over 50% increase in the CO2 concentrations of the atmosphere compared to, in the 19th century. And it would be a lot more if it weren't for the oceans, because of that increase, of net increase in CO2, only about half of it stays in the atmosphere. About a quarter of it goes to building biomass and forest, and the other quarter is absorbed in the ocean. So there's an equilibrium, the CO2 goes and dissolves in the surface ocean, and there's mechanisms to kind of capture that carbon and sequester it, move it down to deep ocean water. So it is moderating the rate of climate change. Now, the undesirable consequence of that, of absorption of CO2, is that at the same time, because of that, the oceans are, quote, acidifying. So just as you have a carbonated beverage, which is slightly acidic because of the CO2, supersaturated CO2 concentrations in it, same thing is happening in the ocean. So it's actually causing this phenomenon called ocean acidification, lowering of the pH of the ocean, which has had substantial consequences and will likely to have. So it's often called, the ocean acidification is called the evil twin of global warming, of climate change, because of this increase, not of temperature alone, but of the CO2 buildup in the surface waters of the ocean. Now, also the warming of the ocean has a number of consequences. You're probably familiar with one I mentioned earlier, and that is the loss of Antarctic sea ice. This is not the ice that sits on Greenland and Antarctica. This is ice which is seasonally variable depending upon the warming trends over the year. But what's happened is that the older sea ice, the more or less permanent sea ice that's many years old, decades old, is diminishing, and the Arctic Ocean is opening up. into more and more ice-free areas. Now, that is not only a problem for the polar bears, but it's a problem for us here living in North America, because what's associated with that is these really weird weather patterns that we have, because that involves the uptake of the warmer, open, darker Arctic Ocean is causing transfers of heat. So before, the ice cover, the radiation would be reflected back in the atmosphere. Now it's absorbing it, and it's changing the weather patterns, the jet stream, the path of the jet stream that flows across the country. So again, this is affecting not just the polar bears, but it's affecting everyone who lives in our country. These changing weather patterns as a result of the ocean opening of the ice sheets. The other thing associated with warming, of course, is that as the ocean warms, you have species that are adapted to live in warmer waters, being able to move farther to the poles as the area of warming waters goes more poleward, from the equator down to the south, and in the southern hemisphere into the north. So you see these range expansions, but on the other hand, you see range contractions. So things that once lived. So a lobster, for example, if you've eaten American lobster, it used to be in the past that they were just as likely to come from sort of south of Cape Cod and Long Island as opposed to Maine. Now you can't get them from south of Long Island. It's moving. They've been eliminated from this area, and so these things are changing rapidly. So these things are shifting, and of course, some things can't shift very easily. And of course, you're probably all familiar with the crisis that we have with coral reefs. Coral reefs depend on their symbiotic relationships with the algae that live in them. It gets to a certain temperature, it doesn't work, and they expel the symbiotic algae. So you have this phenomenon of coral bleaching. The experts on this paint a very dire picture for the future of our coral reefs. It's really sad to see. And I think the science is pretty strong that we will have major loss of coral reefs and biodiversity associated with it. Another aspect of the warming of the ocean is the reduction of oxygen. I'm not talking about just coastal waters like the so-called dead zone in the Gulf of Mexico, but the deep ocean has very little oxygen. And as that water warms, it holds less oxygen, the metabolism is greater. So you have a broadening effect of this low oxygen level in the open ocean. Warming and climate change is affecting currents. You might have seen something in the news recently about more research being done on the slowing down of the North Atlantic circulation, the Gulf Stream that comes in, originates through the Caribbean, comes between Mexico and Cuba, loops around the Gulf of Mexico and heads up past Florida. It all seems to be slowing down. And that's because you've got fresher, warmer water on the surface of the North Atlantic that's not sinking as much. So the whole conveyor belt is slowing down. It's enormous consequences to things like sea level rise along the east coast of the United States and the like. So there are a lot of things, including the dynamics of the ocean and the currents that are being affected. Now, with respect to sea level rise, I think you all kind of know that warming is causing an increase in sea level rise because the warmer oceans are expanding their volume, even though the mass might be the same, at a warmer temperature, the volume expands. In addition to that, now we're seeing the clear signals of a really strong contribution of glacial melt. Continental glaciers are melting and losing mass. That water's going to the ocean. We see now the pretty clear signs of polar ice sheets melting and being lost, including, by the way, because the oceans around Greenland and Antarctica are warming, and therefore they're kind of that warming water is kind of eroding the edge of the ice sheets. And so scientists are very concerned about whether that erosion will get to the point where you'd have a catastrophic loss of these large glaciers in Greenland and Antarctica. So this is a major contribution, is going to be a dominant determinant of sea level rise into the future. Now, the one thing you need to understand about this, most people think about sea level. I say, well, it's going to be 10 feet higher and we better run for the hills. The most important we need to think about is that we don't have to accept that. Sea level is going to rise. We've set it in motion and it's going to rise, but we can affect the rate of that increase. And the only way we can do it is by limiting the warming of the atmosphere, limiting the warming of the earth by reducing emissions pretty quickly. So you know about the Paris Agreement and the agreement to avoid a 1.5 degree warming. That's going to take, and you've heard about the science. Hopefully, you know a little bit about this, why we know that this is going to take getting to net zero carbon emissions by 2050. And that's a heavy lift, but that's going to save us from a catastrophe, not that affects you, me, an old guy, or even you and your kids, but your grandchildren and their children into the future, because this is a fundamental generational challenge. Because the only way we can avoid this is by actions we take over the next 30, 40 years. So in our generation, your kids' generation, it's going to determine what two or three generations beyond this. So it's a fundamental intergenerational challenge. You know that countries all over the world now are pledging to try to meet this goal. Whether we're able to achieve it, it's going to be challenging. We know that the arguments and debates we've had in this country. The good part of that is that there are some, but very few people now are denying climate change. Now, even you have conservative politicians talking about, well, we got to reduce emissions, but not fossil fuels. But at least we've now understand that we need. So dealing with the kids that you educate, it's all right to have this conversation, I would hope. I got involved 10 years ago as a university administrator in the K-12 education on climate change, because I felt so strongly that these generations need to be aware of what's going on. And we're able to work through school boards, state boards of education to get this incorporated into the curriculum. So please emphasize this in your teaching and outreach. The other thing I want to say, and I'm looking at the time, I need to end up about the oceans, is that the oceans are not only the victim of climate change, but they're part of the solution. So we can think about the opportunities for ocean-based renewable energy. Windmills, offshore wind turbines, a recent announcement to even open this in California and of course the East Coast, even in the Gulf of Mexico. And where there are oil rigs now, we want wind turbines into the future. But there's also other ways, geothermal, ocean thermal dynamics, but also in areas where there's large tidal range, we can tap tidal power and the like. We need to do a big job about ocean transportation. Most people don't even think about it, that 90% of what you're ordering through Amazon comes to this country over ships. All right, so what do we do about finding a way to have greener, lower emissions transportation? So just doing that and finding ways to have maritime transportation that's more efficient. Kyla mentioned in the questions, these coastal ecosystems, mangroves that can absorb CO2, can actually counteract some of the emissions that are remaining. But we need to do that quickly, because if we don't, sea level rise is going to wipe them out. So we need to consider that so-called blue carbon. We need to think about how we can use our wealth of the ocean, the fisheries, in a way that replace other kinds of protein that we like. Less beef, more fish, if the fish is done sustainably, these sorts of issues. And then even thinking about potential for carbon storage, trying a way to remove some of this carbon, sequester it, and store it in the deep seabed. This is estimated that just these ocean solutions could be from 7 to 25% of the solution of getting to net zero by 2050. So what you can do, first of all, you know this, you can reduce your own carbon footprint. You can take care about what comes off of the land that you're responsible for, the runoff that goes to the ocean. Plastics is an emerging issue of enormous effect on the world's ocean. look at ways to avoid loss of plastic, the use of plastic recycling, single-use plastics, and so on. Sustainable eat and consume sustainable produced seafood. Affect and and of course, you as educators, the biggest thing you do, those of you educators, is help our next generations understand the challenge and the crisis we have left at their feet, and give them some hope for the future, seriousness of the problem, but hope for the future and how we can address it. And of course, we're all citizens, and so elect and advocate people who get this. We're at a big debate right now, in Washington with this infrastructure bill now about whether the president is going to hold solid that it has to address climate, no deal. I think this is a moment in time. If we don't do this, if we miss this opportunity, it's a really bad signal. So we need to find a way to deal with this existential challenge we're doing in our local communities, in our states, in our nation, and of course, as a global community. So thanks very much. And I'm happy if there's time to answer some questions.
Yeah, thank you so much, Dr. Boesch. We do have a couple questions. Edna asked if you could talk a little bit about the extreme drought consequences of climate change.
Yeah, so one of the consequences of climate change are these extremes. So you go from either extended droughts or heavy rainfalls. So we are seeing, and so this is not equal all over the country. So you see some parts of the United States that in the Southwest in particular, that are becoming drier and drier and have these multi-year droughts. Other areas in the Southeast, for example, where we have this really intense rainfall challenge and increase in precipitation. This is part of the water cycle. So we're bringing water from one place and moving it to others. So it's something we all learn in kind of basic science. And so having people understand that and the enormous consequence, not only in terms of their own water supplies, you've seen Lake Mead go down to record low levels, for example, but also in terms of our food production, but in the ecosystems that depend on a modest amount of water for their survival. So one very direct manifestation of the global climate crisis is a crisis of water in the Southwest United States, resulting in forest fires, agricultural problems, challenges to our water supply, all of those things. Evidence is very clear that this is changed and directly related to human-caused climate change and CO2 buildup, greenhouse gas buildup.
Yeah, thank you. We also have a question from Susan Bartow. She says, in K through 12 education, historically, we focused on carbon dioxide sources and how carbon dioxide held heats in the atmosphere and on personal responsibility. As we come into an age where we know that this problem cannot be solved by individual acts, but we need large-scale systemic change, what would you think the most important things for K through 12 students to know as we build educational programs in climate change?
Well, I think what you said, what you've learned is a good start. So understand the budget for things like carbon dioxide. Also, I should point out that carbon dioxide isn't the only greenhouse gas. And of course, there's very much concern and focus now on methane, some of it released from using natural gas and leakage from natural gas. So don't ignore that too. But it's just understanding the budget is a good exercise for students to understand why the problem is happening, but also what we need to do to address it. So to get us down to net zero, we need to do several things. One is electrify everything so that we're not using combustion of fossil fuels for our energy supplies, in our heating and cooling of our buildings, in our automobiles, electric cars, these sorts of things. Number two, we need to find ways to more efficient ways for transportation generally. And then also, as I mentioned earlier, I'm working in the Gulf Coast now, where this area has been enormously responsible for supplying the rest of us with oil and gas, but also, we don't realize this, but also the plastics, all the chemicals that we use are resulting from natural gas and oil production. We need to find a way to find other ways that we can produce products that are useful, that don't depend on that, or if we have to use them, make sure they don't result in emissions to the atmosphere. It's controversial, but the National Academies just did a study of looking at how do we rapidly decarbonize our nation. And it does involve, it's going to have to rely to some degree on what's called carbon capture and storage. So that from a source like not a power plant, we want to get off of methane, natural gas-based power, but other kinds of things like the petrochemical industry, where you're using a fossil fuel feedstock. Don't let that CO2 out of the plant. Capture it, find a way to store it in the earth. And so those are the kinds of things. So the carbon budget, carbon cycle and the carbon budget is really a very important thing that students can grasp and understand, and then do some mathematical calculations and experiments to understand how do you get there? How do you do a carbon budget and find ways to reduce it?
Okay, thank you so much. If anyone else has a question, oh, we do have one more. Let's see, Bonnie asked, when you talk about electrifying everything, I'm guessing you are suggesting that electricity is created using renewable resources.
That's right. So you have to not only electrify everything, but also you have to create electricity by renewable resources. One of the things in a practical way, this probably also involves the continued use, since we got the capacity in nuclear, but it means that we should avoid the trap of going from coal to generate our electricity to natural gas, because it's a less intense carbon source, but also it hooks us on another fossil fuel technology. So I subscribe to the scientific community that says we should avoid that. We should try to transition directly from old fossil fuels to renewable energy, wind, solar, tremendous potential. There are other kinds, hydropower, but tidal power, those sorts of things that I mentioned. As much as we can go directly to renewables, the better off we'll be. So therefore, when I drive my electric car, I'm satisfied. Oh, I've got an electric car, I've got no emissions, but I do have emissions because some of that electricity I use is spewing CO2 out from, in Maryland, not so much coal burning anymore, but natural gas burning. So we need to get all of that onto renewable energy, all the electricity production to renewable energy.
Okay, and Claire asked if you have any ideas on how to teach what we need to do, avoiding politics, which are very volatile issues.
Well, I actually think science is a very good way to do that. If you introduce people, because it is, this whole climate issue has so much potential in education broadly, because if kids are aware of it, it's becoming known. So to think about that, if we teach climate change, we have to teach, minerals, carbon cycle. We have to teach the water cycle. We have to understand energy. We have to understand the geology of the earth. We have to understand the, biological basis of production. We have to understand all of these things in a way that gets students to look at and trust evidence. See, many of our problems with politics are around not putting evidence aside and having these philosophical. If we can get students just to focus on evidence, let them draw their own conclusions. My experience is, and my hope is, that those students are our best hope for the future. Not just when they become adults and become informed citizens, but now, because they go home and they talk to their parents about this. Okay, and their parents begin to have to open their minds and understand it. And so I think this is really so important, and actually could affect a rapid transition of thinking, not just one that's generational.
Yeah, thank you so much for answering those questions. We are, I think, out of time for question and answers. Is that right, Kyla?
Yes, it looks like we're about there. Yes, thank you so much, Dr. Bosch, for joining us. That was a really wonderful presentation, and I know that all of the educators and supporters of Project WET on this event were really excited to learn more about how they can share science of climate change and oceans and all of that good stuff with their students. So thank you so much.